Okay, so hi guys. So what I want to do in this video is I want to go over radical equations. So if you don't know what a radical is, it's basically just a root, like an nth root. And I'm going to be going over like 7 examples of this because I really want to make sure that we understand how to do those. And by the way, the ones that I really want to emphasize are numbers 5 through 7, because those, well, mostly 5 and 6, because those are the hardest ones, and so I'll leave those for the end. And so we're going to go ahead and get started. So number 1 says the square root of x plus 1 is equal to 4. So this one is pretty simple. The way that you do it, so the square root of x plus 1 is equal to 4. And what you have to do is you have to square both sides to solve for x, right? So this would be x plus 1, because when you square it, the square root cancels out. And this is equal to 16. And then all you have to do is subtract 1 on both sides. And then you get x equal 15, right? So when there's one answer, I mean, you can check it just to make sure. So you would say the square root of the quantity, and it'd be 15 plus 1, and then you would say, is this equal to 4, right? And it's the positive square root. This would be positive square root, right? So positive square root of 16 would be 4, right? And so 4 equals 4, so you're good, right? Now, the next one that we're going to do is number 2. So this is another one that's pretty simple. So we have the square root of x, I think it was x plus 3, or x minus 3. X minus 3 is equal to the square root of 2x plus, or minus 7, my bad. So it's the same idea. You're just squaring both sides, right? And really, you would get a linear equation out of it. So x minus 3 is equal to 2x minus 7, and it's pretty simple. You just subtract x, right? And if you don't know how to solve linear equations, I do have a video of that on the algebra playlist. So yeah, so this is negative 3, and then it's equal to x minus 7, and then you add 7 on both sides, right? And you get 4 is equal to x, right? So then you check it. So you would say check x equal to 4. And the reason why I'm checking it is because some of these have extraneous solutions. So you have to make sure that if one of them does not work, then it's extraneous and you would only have one answer. But I'm checking them for all of them anyways, just to make sure. So we would plug in 4 for x, so be the square root of 4 minus 3 is equal to the square root of 2 times 4, and then minus 7. So this is the square root of 1. This is the square root of 8 minus 7. This is 1 equals the square root of 1. So then 1 is equal to 1. So this works, right? So your solution is x equals 4, right? Okay, so on to the third one. Let me go ahead and write it down. So this one, we have the square root of 2x plus 15 is equal to x. Now, so here's the thing. So basically, yes, you're going to square both sides, right? We square both sides. And we now deal with, so the root cancels out, so 2x plus 15 is equal to x squared. And now we set this equal to 0, right? So you would do minus 2x minus 15 minus 2x minus 15. And so this would be 0 equals x squared minus 2x minus 15. Now you would factor this, right? And for those of you that don't know how to factor, you can like go to a video that I posted previously on how to factor, but pretty much at this point you would have to know how to factor very well, right? But if you don't know how to do it, you can always review it. But basically you want two numbers that multiply to negative 15 and add to negative 2, right? So this would be, 1 second. So two numbers, so it's a times c, right? A is 1 and c is negative 15. A times c is negative 15 and b is negative 2. So the two numbers that multiply to negative 15 and add to negative 2 are negative 5 and 3. So negative 5 plus 3 is negative 2, and negative 5 times 3 is negative 15, right? So then, because this has a leading coefficient of 1, because a is equal to 1 here, you don't have to put, you just have to put the, like, x minus 5 and then x plus 3 equals 0. So then, solving those for x, you do zero product property. So add 5 to both sides, you get x is equal to 5, and then x plus 3 equals 0. You subtract 3 on both sides, you get x equals negative 3. Now, like I said, you have to check it. So our original equation was the square root of 2x plus 15 is equal to x, right? So if we check x equal 5, right? So check, and then it would be x equal 5. We would say the square root of 2 times 5, and then plus 15, and then we would say, is this equal to 5, right? So then we would say the square root of 10 plus 15 equals 5, and we're talking about the positive square root, right? So remember, it's just the positive square root. So then we would say square root of 25 is equal to 5, and then of course 5 is equal to 5, so this checks out, right? And now we have to check x equals negative 3, so we would say the square root, so then check, and we would say x equals negative 3, and we would do the square root of 2 times negative 3 plus 15, and we would say, is this equal to negative 3, right? Because this right here is our equation, right? So we're just doing the same thing, but for negative 3. So then we would say the square root of negative 6 plus 15 equals negative 3. And then, of course, we're talking about the positive square roots, right? So 15 minus 6 is 9. So the square root of 9, we're talking about the positive square root, and obviously the positive square root of 9 is 3. 3 is not equal to negative 3. So this does not work, right? So this right here is extraneous, meaning that it doesn't work. It doesn't satisfy the equation. So your solution, your only solution would be x equals 5, right? So you would say that the solution would be x equal 5, right? So that is how you do that one, okay? So here we have number 4, which says the cubed root of x is equal to 4, right? So all you really have to do for this one is cube it. So this one's pretty easy. We would say the cubed root of x cubed, and then this is equal to 4, and we would cube both sides. So then we would say x is equal to 4 cubed, and then we know that 4 cubed is 64. Yeah, so that would be our answer, right? So that one's pretty simple. Okay, so now we have this one, right? So this is where it gets difficult. So I'm gonna go a little slowly. So the goal is to get x by itself and solve for x, right? Now, here's what I'm gonna do. I am going to subtract the square root of 5 minus x. So I'm gonna go ahead and do that to both sides. So then this gives me, so this cancels out. This gives me the square root of 3x plus 1 equals 4 minus the square root of 5 minus x. Now, we're going to go ahead and square both sides of the equation. So let's see. 1 second. Right, so we're going to go ahead and square both sides of the equation, and this would be, so we would square this side and square this side, right? So this would be 3x plus 1, right? And this would be equal to 4, so it would be like this. 4 minus the square root of 5 minus x times 4 minus the square root of 5 minus x. And you're going to FOIL it out, right? So this would be 3x plus 1 equals, and you're going to do 16 minus 4 square root of 5 minus x minus 4 square root of 5 minus x, and then plus the quantity 5 minus x, right? I'm just following the FOIL method, or the difference of, you know, like the a minus b squared, right? So this would be 3x plus 1 equals 16 minus 8 square root of 5 minus x plus 5 minus x. Okay. So then what you're going to do is you're going to get the square root by itself. So that square root term that you have right here, we're going to go ahead and get that by itself, right? So then it would be, so let's see, we would go ahead and combine like terms. So 16 and 5, that's 21, right? So we have 3x plus 1 equals 21 minus 8 square root of 5 minus x, right, on the outside of the square root. So then we're going to subtract 21 and add x to get that square root by itself, right? Because we really want this by itself, right? So then we're going to go ahead and do that. So we're going to say plus x on both sides, and then minus 21, right? So this would give us 3x plus x is 4x, and 1 minus 21 is negative 20. So this would be, and this cancels out, and then this cancels out. This would be equal to negative 8 square root of 5 minus x, right? Now, we're going to go ahead and divide by negative 8 because we need that square root, or we need that this number in front, we need it out of the way, right? So we're going to divide by the square root of, or I'm sorry, by negative 8. Excuse me. So we're going to say over negative 8 over negative 8. And then we are going to do, so this would be, if we factor out a 4, we have 4 times x minus 5 over 4 times negative 2, right? So this cancels out. I'm just like simplifying this expression, right? And then this is going to be equal to the square root of 5 minus x. Now, we have, let's see, and if I do, okay, so it's x minus 5 all over negative 2 is equal to the square root of 5 minus x. Now, we can go ahead and multiply by negative 2 on both sides. So this would be something like this. Actually, wait, hold on. No, my bad. Not that. We're not multiplying. So what you're going to do is we're going to go ahead and square both sides. So this would be, so let's see, hold on 1 second. Okay, so this would be, so this would be squared, and then this would be squared, right? So then this would be x minus 5 quantity squared over 4 is equal to 5 minus x. Now, this would be, so let's see here. So then this would be times 4 on both sides, and this would be x minus 5 quantity squared equals 20 minus 4x, right? So you're just distributing the 4 in over here, right? It's really 4 times 5 minus x, and you distribute it. So then this becomes, so now we have kind of like a quadratic involved, right? So we're going to expand this, right? We're going to go ahead and expand it. So it would be, so if you don't know how to expand it, you can do FOIL method. Be x squared minus 10x plus 25 equals 20 minus 4x, right? So this is what, that's what this is, right? And now we're dealing with a quadratic. So then you're going to set this equal to 0. So minus 20 plus 4x, and minus, so plus 4x minus 20, and this will give you x squared minus 6x minus 5, I think. Wait, is it minus 5? Hold on. I think I messed up somewhere. Yeah, it is minus 5. It's equal to 0, right? So, obviously this, if you look at it, so if I do, hold on, x squared minus 6x minus 5, 1 second, guys. Or no, I'm sorry, it's supposed to be plus 5. No wonder. Okay, so this is plus 5, my bad. So this would then be, so you would have to know how to factor quadratics at this point. So this would be x minus 3, or no, wait, no. It would be x minus 5 times x minus 1 equals 0. And then using the zero product property, we get x minus 5 equals 0, or x minus 1 equals 0. So then solving both for x, we would get x equal 5, and then plus 1, we would get x equal 1. So then now you have to check it, right? So because there are two solutions, we have to check this, right? Regardless, we would always have to check it just to make sure. So again, the original problem was 3x plus 1, the square root of 3x plus 1 plus the square root of 5 minus x equals 4. So if we check x equal to 5, if we check x equals 5, let's just do, we would get the following. The square root of 3 times 5 plus 1 plus the square root of 5 minus 5, or, yeah, that's what it is. So, okay, yeah, that's what it is. So, the square root of 5 minus 5, right? And this would be equal to 4. So then we have the square root of 15 plus 1 plus the square root of 0 is equal to 4. The square root of 16 plus 0 is equal to 4. And then the square root of, or no, I'm sorry. Yeah, the square root of 16 is equal to 4, so then 4 is equal to 4. So this works, right? So 5 checks out. And now 1, right? So we have to do 1. So now we're now doing x equals 1, right? So you're going to do the same thing, and it would be the square root of 3 times 1, so 3 times 1, and then plus 1 plus the square root of 5 minus 1, right, is equal to 4. So then this would be the square root of 3 plus 1 plus the square root of 4 is equal to 4. So then this would be the square root of 4 plus the square root of 4 is equal to 4. This would be 2 plus 2 equals 4. So then 4 equals 4, right? So this works. So your solutions for this equation, your two solutions are going to be x equal 5 and then x is equal to 1, right? So that is how you do that problem, guys. It's a very lengthy problem. And now we're going to do number 6 next. Okay, so this is number 6. So this one is a little hard, right? So this is the second challenging problem of this video. So you're basically going to do the same thing. You're going to, since one square root is, on the other side, just like we did over here when we were doing putting one square root on the other side, we're just going to square it, right? So this is very similar to the last example. So then you would then get, so this would be 8 minus x equals, and you would do FOIL method, right? So then you would say 2, so then it would be 2 plus the square root of 2x plus 3, and then times 2 plus the square root of 2x plus 3, right? So then this would be, you would do FOIL method with this, and let me write it a little bit better. So this would be 8 minus x is equal to, and you would do 4 plus 2 square root of 2x plus 3, right? And then plus 2 square root of 2x plus 3, and then plus, and then, you know, it would be the square root of 2x plus 3 squared, right? Basically, from here to here, it's this part, right? So you would have to really understand how to do FOIL method to be able to get that. So then what you're going to do is you're going to combine like terms. So you have 8 minus x equals 4 plus 4 square root of 2x plus 3, and then plus 2x plus 3, right? So then you would say, this is 8 minus x. So then you would say, so you have a 4 and a 3, and then you would have, so then it would be 8 minus x equals 7 plus 2x plus 4 square root of 2x plus 3, right? Now, you're going to go ahead and subtract 7 and 2x from both sides. So this would give you 1 minus 3x equals 4 square root of 2x plus 3, right? So you would then have, so you would go ahead and divide both sides by 4, right? And you would have 1 minus 3x all over 4 is equal to the square root of 2x plus 3. And then go ahead and square both sides of the equation to get 1 minus 3x quantity squared over 4 squared equals 2x plus 3, because the root cancels out, right? So then we're going to go ahead and let's see. So we have 1 minus 3x quantity squared over, and then 4 squared is 16. This is 2x plus 3, right? And then from here, what you're going to do is you're going to go ahead and put 16 on the other side of the equation, right? So you're going to get rid of the 16 on the bottom. So we're going to multiply by 16 on both sides. And this will give us 1 minus 3x quantity squared equals 16 times the quantity 2x plus 3. So then this would be 1 minus 3x quantity squared equals 32x plus 48, right? And now we need to FOIL this out. So we have 1 minus 3x times 1 minus 3x. This would be 1 minus 3x, so 1 minus 3x minus 3x plus 9x squared, right? So then it'd be 1 minus 6x plus 9x squared equals 32x plus 48. We can rewrite this in standard form. We have 9x squared minus 6x plus 1 equals 32x plus 48. And now we are dealing with a quadratic equation. So you'd have to set it equal to 0, right? So then we would have minus 32x minus 48 on both sides. So this would give me 9x squared minus 38x minus 47 equals 0. And now we would have to solve this for x, right? So let's see. So then, let's see here. So hold on one second. So of course I would try and factor this out, but obviously it's a very, it's going to be very long if I do that. So I'm just going to go ahead and just put what it is. So it's x plus 1 times 9x minus 47. And then this is equal to 0. So we have x plus 1 equals 0, or 9x minus 47 equals 0. So then we would do, so subtract 1 here, and we would get x equals -1, and then add 47 over here, right? And we would get 9x equals 47, and then from here we would go ahead and just divide both sides by 9, and we would get x equals 47 over 9. Now to check the solutions, we have to plug it back in. So our original problem was the square root of 8 minus x. So the square root of 8 minus x is equal to 2 plus the square root of 2x plus 3. So 2 plus the square root of 2x plus 3, right? So we're going to plug in x equal -1. So we have 8 minus -1. And then is this equal to 2 plus the square root of 2 minus, or 2 times -1 plus 3, right? So this would be 8 plus 1 equals 2 plus the square root of -2 plus 3. This is 9 equals 2 plus the square root of 1, which is, oh, and by the way, it's supposed to be square rooted. My bad. So the square root of 9, so it'd be 3 equals 2 plus 1. And we obviously know that 3 is equal to 3, so 2 plus 1 is 3. So this checks out. And now we're going to do 47 over 9. So the square root of 8 minus 47 over 9, is this equal to 2 plus the square root of 2 times 47 over 9 plus 3, right? So we would do 72 minus 47 over 9 square rooted is equal to 2 plus, and then that would be 94, square root of 94 over 9 plus 3. And then you would say, so this would be like 35 over 9. So the square root of, or no, I'm sorry, no. So 72 minus 47 is, so it's 25. So the square root of 25 over the square root of 9 is equal to 2 plus, and then it would be the square root of 94 plus 27 all over 9. So then this would be 5 over 3 is equal to 2 plus, and 94 plus 27 is 121. So plus the square root of 121 over 9. So this would be, 5/3 is equal to 2 plus, and the square root, so it'd be plus the square root of 121 over the square root of 9. This would be 5/3 is equal to 2 plus, and I think it's going to be 11 over 3. And then obviously we would say 5/3 is equal to, it's going to be 2 over 1 plus 11 over 3. So that's 6 plus 11 over 3. And obviously this would not be true, right? This would not be true. I'm pretty sure the square root of 121 is 11. Let me just make sure. Yeah, it is. So it'd be 2 times 3, which is 6, plus 11 all over 3. And this becomes 5/3 is equal to 17 over 3, which is not true. So obviously x equals 47 over 9 is extraneous. So this does not work. This is an extraneous solution, right? So that was number 6, and then hold on. And now we're going to do number 7. Number 7 is going to be the last one of this video. So number 7 is really not that complicated. It's 2, the square root of 2 minus the square root of x. So the square root of 2 minus the square root of x is equal to the square root of x, I think. Yeah. So what we're going to do is we're going to go ahead and square both sides, right? So square both sides, right? And then we have 2 minus the square root of x. So 2 minus the square root of x equals x, right? So then this would be, so then let's see here. We would go ahead and subtract 2 on both sides. This would be negative square root of x equals x minus 2. And then you would square both sides, right? So this would be x is equal to x minus 2 quantity squared. If you FOIL this out, you would get x equals x squared minus 4x plus 4, right? So then you set this equal to 0, and you would say 0 equals x squared minus 5x plus 4. And then from there, this would be 0 equals the quantity. It could be x minus 4 times x minus 1 is equal to 0, right? So then you would have x minus 4 equals 0, or x minus 1 equals 0. So then this would be, so you would add 4 to both sides, get x equals 4, and then over here you would add 1 to both sides, and you would get x equals 1. So these would be your two solutions. Now, like I said, you always have to make sure and check it. So when we check x equals 4, so we do x equal 4. Let's just do it this way. We're going to do the square root of 2 minus the square root of 4 is equal to the square root of 4, right? This is the square root of 2 minus 2 is equal to 2, right? Obviously, the square root of 0 is not equal to 2 because 0 is not equal to 2, right? So this is extraneous. And then we're going to check x equal 1, right? So now we're going to do x equals to 1. So we have 2, so the square root of 2 minus the square root of 1 is equal to the square root of 1, right? So this is the square root of 2 minus 1 is equal to 1. And we know that the square root of 1 is equal to 1 because 1 is equal to 1. So this checks out. So your solution is x equals 1. And we know that x equals 4 is an extraneous solution. Okay, guys, so that was a very long, it took a little longer than expected, but if anyone has any questions about this, or if you did find number 5, 6, and 7 difficult, don't get discouraged. Those were challenging, okay? So those were more challenging than the first 4 that we did. So really, this, I mean, yes, it's important to know how to do this, but they're more challenging than anything. So if you don't understand it, it's okay. Just keep practicing it and review what I did here. And with that being said, guys, thank you so much for watching. Please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.